Reciprocal linear trig equations. In this module, we'll take trigonometric equations, like for example 5 times cosine of theta minus 4 equals 0, and attempt to solve for the angle, usually on the interval from 0 to 360 degrees, submitting our answers to the nearest tenth. We'll usually want to go about this by first isolating the trigonometric portion of the equation, and then thinking about what that means in the context of the unit circle. So for example, we might begin here by adding 4 on both sides of this equation, giving us 5 times cosine theta equals 4, and then dividing by 5 on both sides of the equation. That gets us that cosine theta is equal to 4/5. Recall that on the unit circle, cosine is represented by an x-coordinate. X equals 4/5 we can represent with a vertical line, and we can see that we should expect two solutions, one in quadrant 1 and one in quadrant 4. To find this first solution in quadrant 1, we'll want to pull up our calculator and then press this functions button in order to use the inverse cosine function, making sure of course that we're in degree mode. In this case, we can type in the inverse cosine of 4/5, and we can see that we're getting back an answer of 36.9 degrees. And so, in quadrant 1, this must be a 36.9 degree angle. But because we're expecting two solutions, first of all, we'll click this plus sign. Second of all, we can type in that the first solution, 36.9 degrees, and then third of all, we want to think about what that 36.9 degrees has to do with the solution in quadrant 4. One way to think about it is to rotate from the positive x-axis clockwise, which means this would be a negative 36.9 degree angle. But the problem is that our interval begins at 0 degrees, so we're not interested in a negative solution. What we can do to adjust, however, is make one full rotation of 360 degrees. In our on-screen calculator, what that would look like is 360 plus the negative of that 36.9 degree solution, which you can see gives us back 323.1 degrees. And so that is the second and final solution that we'll go ahead and submit. And as we do so, we can see that we have correctly solved this trigonometric equation. Let's consider another example. 6 cosine theta plus 7 equals 0. Again, we might begin by isolating the trigonometric portion of this equation, subtracting 7 on both sides to get that 6 cosine theta equals negative 7, and then dividing by 6 on both sides to get that cosine theta is equal to negative 7/6. But this time, if we attempt to draw in something like x equals negative 7/6, we can see that we're far enough away from the origin that we're no longer on the unit circle at all, which means in this case that the problem has no solution. We can go ahead and simply select Submit Answer, and we can see that we've correctly identified a trigonometric equation with no solution. On the other hand, consider an equation like 3 times cosecant of theta plus 8 is equal to 0. Again, we'll begin by subtracting 8 on both sides, getting 3 times cosecant theta equals negative 8, and then dividing by 3 on both sides to get that cosecant theta is equal to negative 8/3. Cosecant, of course, is the reciprocal of sine, and so we could rewrite this as 1 over sine theta is equal to negative 8/3, and then using the reciprocal identity, we could say this is the same thing as sine theta is equal to negative 3/8. From there, we'll want to keep in mind that sine theta represents a y-coordinate in the context of the unit circle, and so we can represent that as a horizontal line going through negative 3/8, which would give us two solutions, one on the unit circle in quadrant 3 and one in quadrant 4. As we pull up our on-screen calculator and use the inverse sine function, we want to recall that the inverse sine function always returns values between negative 90 degrees and positive 90 degrees. So as we take the inverse sine of negative 3/8, we're going to get back a value of negative 22 degrees that we can represent here in quadrant 4. But as we saw with an example earlier, we're interested in the interval beginning at 0 degrees, so we have to complete one full revolution here or add 360 degrees to that negative 22 degrees. When we type that in, we get a solution at 337.97 degrees, which is going to round up to 338 degrees. But it's not our only solution, so we can also click the plus sign here and try to figure out this other solution in quadrant 3. We could reflect this same 22 degree angle into quadrant 3, and then just keep in mind that we need to add 1/2 rotation, beginning of course from the positive x-axis, meaning that we'll take a positive 22 degrees, which could come in our on-screen calculator from the negative of the inverse sine of negative 3/8, and then add 180 to that. With our two solutions now, we can go ahead and submit this answer and see that we have correctly solved this trigonometric equation.